really rather gruesome. This behaviour is almost unique in the animal kingdom, but it's crucial to their survival. And they live here in the rainforest beneath me. In this large hollowed tree, there live several different species of bat. And in a few minutes, as it begins to get dark, they'll fly out and look for food. Now, the species of bat that I'm interested in doesn't live on fruit or insects, which is usual. They have a slightly more exotic diet. These bats inspired a Gothic horror story. And just like the mythical monster, they are creatures of the night. So we filmed them with a night vision camera to get really close to them. It's obvious from his teeth what this bat feeds on. This is a colony of vampires. They drink blood and they're hungry. Oh, you vicious brute. Look at your evil face. I'm going to let you go. Despite their Dracula-like fangs, feasting on blood is not as easy as it sounds. Just like the fictional character, real vampires have only a few short hours to feed before dawn. The victims are often farm animals. Gruesome as this may look, the sleeping victim is unaware. The bat's saliva numbs the wound, whilst ensuring a steady flow of blood. It's 4 o'clock in the morning, and the vampires are flying home. Hopefully, they all will have found food. These animals have a very rapid metabolism, so just 48 hours without a meal means certain death. But this is where these resourceful creatures come into their own. For those unlucky enough to come home still hungry, help is at hand. The vampires live in small groups that have evolved to cooperate. One bat will regurgitate blood for another bat who's failed to find food. This generosity makes a dramatic difference to the survival chances of the whole colony. But beware any bat who takes blood and refuses to return the favour. They'll be remembered and shunned in future. This kind of generous behaviour is exceptionally rare. In fact, vampire bats are one of the only species ever found that remembers favours for more than a brief, fleeting moment. Except for we humans, of course. Thank you. As animals go, we humans are really very generous indeed. In fact, we are naturally the most generous of animals by far. Most of us would think nothing of lending somebody the money for lunch or buying a round of drinks in the pub. But exactly like the bats, when we're generous, our instincts are crying out for us to be repaid. Cheers. After all, being generous might backfire. We could leave ourselves vulnerable to people who take but don't give in return. It's pretty annoying being conned out of a pint of beer. But there was rather more at stake for our distant ancestors. In the harsh prehistoric world of early humans, not being repaid could mean starvation and death. Somebody must have been generous to the owner of this jawbone. Left to themselves, they would have starved as their teeth fell out. But if there was an instinct to help others, thousands of generations ago, there had to be something else. Generosity could only have evolved if early humans had just as keen an instinct to detect somebody who was simply on the take. A cheat. We all have a powerful gut reaction when we feel we're being treated unfairly. It's an instinct that's with us from childhood. In this experiment, 7- and 8-year-olds are sharing a stash of 10 chocolate coins. One child decides on how they are split, and they can offer as many or as few coins as they like.
I'm gonna give her 2. You get 3. So you get 1. You get 3.
At first, they keep more for themselves, but there's a catch. It's the other child who gets to decide if the split's fair. If not, they can refuse the offer. And then, both children have to go away empty-handed. Will they get away with it?
No. I said no. No. What do you mean? That means you don't get any chocolate. I don't care. It's already too little.
Almost all of the children reject a smaller share, preferring to have nothing at all. It may seem strange, but it's not. By going without themselves, they're punishing their partner who loses even more chocolate. And they're not going to forget that in a hurry. Look what happens when the experiment is repeated.
She gets 5 and I get 5. Okay. You get 4. Okay, I gotta give you 5 coins for you and 5 for me. I'm gonna give you 4.
Now, with a fairer split, what will the response be?
Yes. I'll say yes this time. Yeah. Yes.
The children are happy to accept. It's not difficult to see why we've evolved this way. If we react instinctively against people who cheat, they'll think twice before trying it again. This instinctive taste for fairness leaves humans free to help one another. All of us have the instinct to help other people. Watch how unsuspecting shoppers react when they see our stuntman take a fall.
Oh, it's all right, lovely, yeah.
When they see him in trouble or in pain, they react with compassion. It's as if they feel the same pain too.
It's all right. Thanks very much. Thank you very much.
Okay.
They're experiencing a particularly human instinct called empathy.
Never mind, sweetheart.
Yeah.
Scientists in Italy are probing the brain to find out how we are able to put ourselves in other people's shoes. The team here have devised an experiment to show how the brain does something truly amazing. It reads other people's minds. The experiment involves magnifying the brain signals responsible for imitation. But to show how it works, the scientists need a human volunteer. So here goes. Recently, they've discovered a special set of brain cells. They're called mirror neurons, and what they do is remarkable. The theory is that when I see someone performing an action, my mirror neurons should try to copy the action too. But normally this effect is so subtle, I'm not even aware of it. The mirror neurons alone can't actually make my hand move, so to reveal them working, I need a little help. This equipment uses a powerful magnetic field to amplify the effect of my mirror neurons. But first, they have to find exactly the right spot in my brain.
Nothing?
You sort of fry my brain, don't you? We're on target. Right, now we come to the crunch. We'll see what happens when I watch the video screen. If the mirror neurons are working, when I watch the picture of the hand grasping, my hand should twitch. Yeah, I felt a twitch. Yes, it may be just a small movement, but my hand's actually moving without any conscious help from me. And this reveals something amazing. Our brains are programmed to mimic the actions of other people. So my hand moved then when it wouldn't have done before. But because I was watching the picture and empathizing with what I could see, my hand moved. This pioneering work leads some scientists to believe that our mirror neurons don't just imitate what other people do, but perhaps even how they feel. Empathy is so important to us that we're all born with a highly specialized mechanism to help share our feelings. The human face. The anatomy of the human face is unique in the animal kingdom. 47 muscles working together to reveal our emotions. Joy. Anger. Sadness. Disgust. We express our feelings in our faces spontaneously, and our expressions are the same the world over. But why should millions of years of evolution have left us with such a sophisticated tool for empathy? Well, knowing what someone else is feeling can be very useful. Like whether they're pleased to see us or not.